Center for the Ethiopian Educational Information and Communication Technology presents Educational Satellite Television Programs.
Hello, teacher. Hello, students. Welcome to today's lesson on circles. In the last lesson, you learned that a locus is a system of points, lines, or curves on a plane. You also learned about the plane curves that can be formed from conic sections, including circles, parabolas, ellipses, and hyperbolas. Today, we will focus our attention on a specific conic section, the circle. Are you ready, students? Let us start the lesson. Suppose that you are given this description of a locus. This locus is the set of all points in a plane, which are a distance of 6 units from the origin. Is there a plane curve that matches this description? What about a circle? A circle is the locus of a point that moves in a plane with a fixed distance from a fixed point. The fixed distance is called the radius of the circle, and the fixed point is called the center of the circle. From this definition, for any point P at x, y, on a circle with center C at h, k, and radius r, where PC equals r, the distance formula tells us that r equals the square root of x minus h squared plus y minus k squared. By squaring both sides of this equation, we get x minus h squared plus y minus k squared equals r squared. This equation is called the standard form of the equation of a circle with center h, k, and radius r. Students, this is an important equation. To ensure that you understand it, please write down the standard form of equation of these circles.
Students, let's get ready. Begin. Time's up. Let's get back to our lesson.
Hello again, students. I am sure you did not find that activity too difficult. When h equals -3, k equals 8, and r equals 4, the equation of the circle is x plus 3 squared plus y minus 8 squared equals 16. For the second question of this activity, let r be the radius of the circle. The equation of the circle is x minus 3 squared plus y minus 2 squared equals r squared. Since the point P is on the circle, we get -4 minus 3 squared plus 1 minus 2 squared equals r squared. This gives us 49 plus 1 equals r squared. So r squared equals 50. Therefore, the equation of the circle is x minus 3 squared plus y minus 2 squared equals 50. Now that you know how to write the equation of a circle, let us try to work backwards to find the center and radius. The equation of a circle is x squared plus y squared minus 8x plus 12y minus 12 equals 0. Students, please find the coordinates of the center and the radius for this circle.
Students, let's get ready. Begin. Time's up! Let's get back to our lesson.
Hello, everyone. That question was a little more complex. Let us look at the solution together. The first step is to change this equation into the correct form by completing the square. We group the similar variables together. Then, we complete the square for each variable. Because we have added 16 and 36 to one side of the equation, we must balance the equation by adding this sum to the other side. Now we are left with x minus 4 squared plus y plus 6 squared minus 12 equals 52. We move the 12 to the other side of the equation. So, the center of the circle is at 4, negative 6, and the radius of the circle is the square root of 64, which is 8. Did you arrive at the same answer? Great work, students. Earlier in this unit, we learned the distance formula for finding the perpendicular distance from a point to a line. We can use the same formula to find the perpendicular distance from the center of a circle to a line. The equation of a circle is x minus 1 squared plus y plus 4 squared equals 16. The equation of a line is 3x minus 4y minus 1 equals 0. The distance formula looks like this. H and K are the coordinate points of the center of the circle. From the circle equation, we know that these points are 1, negative 4, respectively. Students, please use the distance formula to find the perpendicular distance between the center of the circle and the line.
Students, let's get ready. Begin. Time's up! Let's get back to our lesson.
Welcome back, students. By substitution, we get distance equals 3 times 1 plus -4 times -4 minus 1 over the square root of 3 squared plus -4 squared. This gives us 18 over 5. So the distance from the center of the circle to the line is 18 over 5, or 3.6 units. If the perpendicular distance is less than the radius of the circle, then the line intersects the circle at 2 points. This is called a secant line to the circle. If the perpendicular distance is equal to the radius, then the line intersects the circle at only 1 point. This is called a tangent line to the circle. The point of intersection is called the point of tangency. Finally, if the perpendicular distance is greater than the radius, then the line does not intersect the circle. We will study these points of intersection in greater detail in the next lesson. Today, we learned how to write the equation of a circle, and we practiced finding the radius and center of a circle from its equation. We also learned how to determine the distance between the center of a circle and a line. Until next time, thank you, teacher. Thank you, students.